Welcome to week 3 of Advanced R for Geography 473-673 at University of Delaware. This week we're going to be covering a ggplot2 tutorial. And ggplot2 is pretty much, it's arguably the most popular visualization package that R has to offer. And it is it's so widely used for so many different purposes, from business to actually plotting and visualizing graphs and different metrics for publications. ggplot2 has a ton of customization, even more than just the base graphics. And so just as a reminder, for the first 2 weeks here, we were only dealing with base plotting. So we didn't have to load in any external packages. We were only using exactly what R gave to us. And now we're going to be only focusing on ggplot2, and there's so much that we can do with it. So let's get started. So far, we've only been dealing with base graphics. And we've seen that basically the only thing that we need to do for those graphics is we need to give it some sort of vector. So if we plot a scatter plot, we just need a vector of x and y values. Or if we want a pie chart, we just need some sort of factor that has vectorized values, a number of tree species, and for a bar plot. ggplot2 works a little bit differently. So ggplot2 has been designed to work with data frames. So we know data frames in and out by this point, and ggplot2 is automatically designed to work right with these data frames rather than individual vectors. The other difference about ggplot2 is that the syntax is slightly different. So when we added plots before, for example, we had a point plot, a scatter plot, and we wanted to add lines to it, we could use the lines function to add to that earlier plot, or the points function to add to an earlier line plot. ggplot adds extra layers to a plot using the plus symbol. So it's going to seem a little bit weird at first. It's different syntax, but after you get a little bit more familiar with it, I think that you'll find ggplot2 to be a pretty cool package. So the first thing that we're just going to cover here are just some very basic ggplot2 functions and descriptions. And the first is ggplot. So ggplot2 is the package, but we use ggplot as the function. Yes, there was an earlier version of ggplot called ggplot, and so that was formerly ggplot1. But this has been deprecated and is no longer used. ggplot2 kind of went way above and beyond, and so they just sort of said, yeah, we don't need ggplot1 anymore. So that's why we have ggplot2. Now, ggplot works with aesthetics, and so that's its term for adding layers to a plot. So we have aesthetics that we are going to add to a ggplot instance. So ggplot says, hey R, I want to create a new ggplot window. Then we can add aesthetics, which might be the variables of a data frame or a specific map, etc. We can add all of these different functions to our ggplot instance, such as a line plot or a point plot or a linear regression plot or a density plot. It doesn't matter. We're just going to use the plus sign to add these different functions and in turn layers to a ggplot instance. So you have this up here if you need to reference it. Don't worry if it doesn't make sense just yet. Let's dive in and hopefully things will start to click. So the first thing here is I'm going to open up ggplot. Next, what we're going to do is I'm just going to read in a CSV, and that dataset is acadia.csv from the datasets folder, and I'm just going to go over this just in case somebody has been doing things a little bit differently. All of the datasets that you need are in the course datasets folder, which is, here's a link right here. This is the course GitHub, and we have the link to the datasets right here. But you don't actually need to download these files individually or one by one. You can download all the code, download it as a zip file right here, and now you can just access the datasets folder on your local machine as opposed to on GitHub. I would recommend doing that ASAP. Once you have it all downloaded, we're just going to read in the CSV. And what this actually is this is showing the number of visitors per year at Acadia National Park. So, and for those of you who don't know, Acadia National Park is a national park located in Maine. It's stunning, and this is the number of viewers for each year since 1919. So, first we're just going to remove the X column. We don't need it. It's just row numbers. And now what we're going to do is let's start by plotting the ggplot. We're going to first open up a ggplot instance, right? So we're going to say, okay, hey, I would like to create a ggplot. I want my data frame to be Acadia. And I want the aesthetics to look like, I want the X to be the year of Acadia. So right here, the year. And I want Y to be the visitors. So here we go. Okay, there's no plot in there, or is there? There's no line, but look at what happened. We have visitors as our Y axis. So is this on the order of magnitude 2e to the 06? Yeah, that's on the magnitude for sure. And then year, okay, yeah, 19. We have 1919 all the way out to, let's see, all the way up to 2016. So yeah, this makes sense, but here's why nothing happened. We didn't tell it to add a line geometry or a point geometry or anything. We only created the ggplot window. That is all that the ggplot function does. It says, hey, I want to create a ggplot. I want the x-axis to be the year of the Acadia dataset, and I want the y to be the number of visitors of the Acadia dataset. So if we wanted to add the actual values to that, all we would have to do, I'm going to remove that, is add with the plus sign the geom_point function. Now we actually have values. And so all we had to do is add in this geom_point. It already had in geom_point takes x and y values, but it already knows what they are going to be because they were predefined aesthetics within the ggplot instance over here. So conversely, we can add a line plot to that as well. And it looks rather similar. It works the same exact way. So this is how ggplot works, and we can keep adding different functions to this. We can add a geom line to a geom_point. And so this is pretty much how ggplot works. We start with an initial data frame. We give it aesthetics. We say, hey, I want my x to be this. I want my y to be this. Here's my geom_point, geom line, etc. We can also add remember last week we were going over linear regression? We can very quickly just add a linear model via the geom_smooth function. We can crunch the linear model for visitors and year, and that's how simply it'll plug that in for us. So this is our trend line, and then this is our degree of uncertainty right here. So this is our trend, and I think that's probably the 95th percentile confidence range. So yeah, there we go. That's as simple as that. All we have to do is add geom_smooth, and the method we're using is a linear model, LM. So that's kind of how ggplot works, and how it flows. And the other thing that is kind of interesting here about ggplot is all of this is done in one line here, but instead of doing that, we could do things like this. So let's just say g1 equals ggplot of Acadia, right? So we have our g1. Okay, and then we can actually take g1 and we can plot it just by printing g1. So g1 is actually stored as an object, but it's a ggplot object. And all we need to do is print that object out for ggplot to work. But the other interesting thing is that we can actually add things to the plot. So we can add G1, or can we add geom_point and geom_smooth to G1. And now when we print G1, it's the same exact plot as before when we had it all in one line. So that's another cool thing about ggplot. We can save things as objects, which is pretty cool. And so this is just another example that you can add it bit by bit. It doesn't matter. So the other thing that we can do here is we are not necessarily restricted to only using the aesthetics prescribed in the ggplot instance. So for example, I'm going to create some dummy data, and it's just going to be the Acadia dataset, but we're going to divide the total number of visitors by 2. Okay, so simple as that. Same thing, only the total number of visitors has been divided by 2. So it's just some raw data. And now what I'm going to do is I'm going to plot it up, and now look at this. Instead of giving aesthetics to the ggplot, I'm just going to give it a data set. I'm going to say, I'm going to give you Acadia, okay, ggplot. So that's your data frame that you're going to work with, the Acadia data frame. Now what I want to do here is I can actually just add the aesthetics within the geom_point function. So it doesn't matter which function you add the aesthetics to. You can add it to the main window, you can add it to the geom_point. It doesn't matter as long as ggplot is given the information that it needs. Now, if we come back up here and we move the aesthetics over here to geom_point, because the aesthetics are only within geom_point, geom_line will have no idea what to do because it is not given the aesthetics. And so that's why geom_line requires the following missing aesthetics, X and Y. So we would have to add the aesthetics there individually as well. And now back up here we get that original plot that we were chasing. But now what happens when we want to add in a different data frame, in this case dummy data? So we have the geom_point where we used this data set right here, the Acadia data set, the normal one. Now what we're going to do is we're going to add geom_smooth with the Acadia data set and same aesthetics right there. And here's where things change. So this is a really long line of code. Now I'm going to add a new geom_point to this data set, and I want the data now to be dummy data. And the aesthetics here are still going to be year and visitors, but this works because year is the same, but remember the visitors have been cut in half. So as long as I prescribe the data set that geom_point is working with to be different, it still works. And so the same can be said up here. I can replace, as long as I provide the data set and the aesthetics for each of these functions, ggplot will understand what you're trying to do. So now I have, and same for geom_smooth right here, I'm going to add that linear regression line to the data set, only this time I want to use dummy data again. And the aesthetics are still going to be year and visitors. So now when I plot all this up, oh, can't do that. I need to put that back. So if you're going to add different things, you have to leave the plus sign at the end of the line. So there's G, and now I can just plot G or print it, doesn't matter. And boom, there we go. So red is our initial Acadia data set, blue is our dummy data, and we see the different linear regression lines, both on the same ggplot window, but with different data frames. We can also crop different areas out using xlim and ylim, and so that's how we would make something like this. So we have our ggplot, and we're just going to be making this simple. It's just going to be our Acadia data set, not our dummy data. And then we're going to add xlimit and ylimit functions here. So we're really just going to constrain the data set. Whoops. And so yeah, so we see right here we've constrained everything to just 2000 to 2017, and that's what we've been doing. So now a key thing to say is that it's going to delete points. So in other words, we're calculating a new regression line just for this subset of the data. Instead of cropping out, we can actually zoom in and out on the data set so that we can preserve our initial trend line and preserve our initial data. So, and sometimes you're going to want to subset a data set. This is one way you can actually subset, because we're subsetting only between these years and these values, but all these values are within our LY limit for the number of visitors. But this is cutting out all of the data before 2000 and crunching a new trend line. It's calculating a new trend line from 2000 to 2016. However, if we just want to zoom in and zoom out, we can use Chord Cartesian instead of the xlim and ylim functions. Now, Chord Cartesian operates very similarly. We have to provide arguments of xlim and ylim that are the same arguments up here, but remember, look at this. It's a function. This is the xlim function. This is the xlim argument within the Chord Cartesian function. And now, notice how our trend line is way, way, way different because it's the original trend line. The original trend line from the full data set. So this is not removing any data. And you can actually see this in the warnings too. When we use xlim or ylim functions, it's telling you, say, hey, we removed 81 rows of data. And for this one, it's no warning. Why? Because we're just zooming into that specific point. Well, I keep going over to uploading my previous video to YouTube right now. Ignore that, please. So now what we can also do is we can add different labels, and we can adjust the X label, the Y label, the title, we can add a subtitle, and so that looks like this. So we can use the labs function, so we can add labs, and we can define a title, a subtitle, a X and a Y, and we can even add a caption. So very quickly in ggplot, we're making publication quality material with a lot of different information. Now, we use the labs function up here, but as with everything in R, there's multiple ways to do things. So we can use ggtitle, where it'll take a title and a subtitle, then it'll add xlab and ylab using the xlab and ylab functions instead of labs. It doesn't matter what you use. Both going to yield the same results, but just a different way of coding it. Now, you can also work on sizes and colors. They take size so that we can adjust the size of the line, the color of the line for geo and line, and we can adjust the size of the points and the color, and we can add all of these things to make it really customizable. So there you have it. There's a ton of customization available pretty quickly once you get used to the syntax. And as a reminder, we need to add, if you're going to add things to a specific plot, just make sure the plus sign stays in the same line or on the line before. But we can't initiate a geomline function or any other ggplot function with the plus sign down here. So you guessed it. Now we're going to dive back into the Willow Creek meteorological data set that we used last week. And this week, we're going to use ggplot2 instead of using our base plotting. So we're going to open up the data. I already went through this last week. We're going to change the names to our new short names. And we are also going to add our date sequence variable. So that's all that's going on here. So I'm just going to kind of brush over this because, as I said, I already went over it last week. So right here, now we read in our Willow Creek data set. This is what it looks like, head of Willow Creek. our date time, our tear, all that good stuff, all the same variables, same data set. But now let's plot a point plot of shortwave radiation, or S wave, of this data set. So what we're going to do is, here's my data frame that I'm going to give to ggplot. I'm going to add a geom point, and this is redundant. I don't actually need to define my data set again because I already defined it up here, but I just did it out of complacency's sake. Add my aesthetics. I want my Y to be S wave, my X to be date time, color it, size it, create an alpha, which changes the transparency so it's half transparent. Add labels. And the last thing that I'm going to do here is I'm going to scale color manual. So what this is going to do is actually going to, it's just one way to color things specifically. And so what we did there is we just said, okay, I want shortwave radiation. That's my label. This is just a way to label things. I want it to be firebrick. So we colored it and labeled it all in one instance. And so look what's going on here. We colored it in geom point. We decided the color would be shortwave radiation. That is not a color in R, but we keyed in right here. So basically what's going on is it's substituting, this ggplot instance is substituting wherever it sees shortwave radiation, substituting firebrick. So that's why you have this firebrick red color right here. So that is the simplicity of ggplot. Once you get used to it, it's very nice. It's actually pretty intuitive, and it can make some really nice looking plots. Now, this is a nice little scatter plot here, or a point plot of this shortwave radiation. But now let's plot a density plot of specific humidity. So we're changing up the variable. Now we're going to use SHUM for specific humidity. And we are going to plot a density plot of it, so geom density right here, and then we're going to add things just the way we did before. We're also going to add a fill. So the geom density function works a little bit differently than geom point or geom line. Notice that the aesthetics, because we're making a density plot, right? So we're only concerned about the total number of values for each specific humidity value. So we're counting up the different bin windows of specific humidity. So y is equal to ... density ... Yes, it has to be that way, and this is the way that geom density works. So that is what y is going to be equal to. We're going to color specific, the color is going to be specific humidity, which we define down here in scale color manual to be firebrick. Add a size, and we add an adjust parameter, and all that the adjust parameter is, let's see if I describe it in here. Adjust is, it's the term for bandwidth. So we're just adjusting it to a bandwidth of 1. So make this plot. And there's our density plot of specific humidity. So you see that very quickly we have some pretty nice looking plots here, all using ggplot. And so now we've kind of covered the basics here and gone through the Willow Creek data set. So for the assignment, we're going to use the Willow Creek data set again. We're going to use the 2012 Willow Creek data set. So again, so just weather variables of the year 2012 in Willow Creek, Wisconsin. And we're going to create a geom line plot for air temperature. You're going to add a trend line to this plot, include titles, axes, labels, colors, etc. And we're also going to create a density plot of air temperature with the appropriate titles, X labels, Y labels, legend, etc. And you're going to submit both plots to University of Delaware Canvas under the assignment. So here's what they look like. These are my colors. You can use whatever colors you want. So this is what the 2012 air temperature looks like. It has a slightly positive trend line throughout, and then this is what the Gaussian densities look like. And if you want extra credit down here, you can use all 3 of the Willow Creek data sets. You can create a density plot with each year being a component, and you can adjust the alpha settings and line types to make each line look distinguished. And you can add them all to the same plot, so you can compare the different densities for the different years. So again, this is for air temperature. And then just submit the assignment to as extra credit PNG to the week 3 or just the ggplot assignment.